And I should also just say that I neglected to do this at the top of the hour, but we are going to start recording now. So I apologize. I missed my own message to myself to start recording at right at 2. So we missed our introductions, but this recording will then be available to all of you after the fact if you'd like to retrieve it later, starting apparently now. So.
Okay, so now you are recording, Teresa.
I am. Yep.
Great, thank you.
Mm-hmm.
So when we think about like, why do we want to do this? Why do we want to have good questioning techniques? Why do we want to have good dialogue in our classes? Something that really strikes me that I learned from modeling, and like I mentioned in my introduction, that I was trying for years to have dialogue with my students about how do we know these things that we know, and to get students talking. And I struggled with that. And when I took my first modeling course, the thing that really struck me is the idea that in retrospect seems so obvious to me now, but wasn't before, is that if I want to know what my students are thinking, then I have to make them tell me. And inviting them to tell me, asking them to tell me what they're thinking isn't good enough. So, I have to restructure my class so that it's just built into the class that they're telling me what they're thinking. And that's harder to do than to say you want to do it, of course. But so to me, it comes down to finding ways to pull out of them what their thoughts are, because, how do I address what my students are actually thinking? How do I teach my students where they are right now if I don't know what their thoughts are? So, and when I do know what their thoughts are, then I can better help them navigate towards figuring things out for themselves. And when I'm having dialogue with my students, my aim isn't to get the answer. Now, my students expect that, because that's how they've been trained for years and years, is that, like the purpose of teacher questions is for somebody to say the answer. And then once somebody says the answer, we move on. And I have to work really hard to untrain that, because the point for me isn't to get an easy answer. It's to uncover their thinking and to develop their understanding. And that also means sometimes we can end a conversation without having a conclusion, without having a consensus, and we can agree that we need to regroup tomorrow and approach this from a different angle. Teresa, is there anything you want to add?
Sorry, I had myself muted. No, I will ditto on what Jeremy said. I also want to thank everyone who's pitching in on the chat. I will try to monitor the chat. Laura mentioned that she's hoping that for tips to structure the questions that will help lead to the answers that she wants. And I think probably a lot of us have and continue to feel that way. And so we will definitely try to make sure that you leave here with some tools in your toolbox. For some of you, your toolbox might be brand new, and for some of you, you might have been carrying it around for 35 years. But nonetheless, we hope that all of you will feel that you've got a couple of good ideas that you can use tomorrow if that's when you need it.
Yeah, and I see Megan posted in the chat that, Megan, your students hate leaving a conversation unresolved. Mm-hmm. And so do mine. Although, there are times when we're not going to get there today. And, so we have to we've got two choices. Either I just tell you the answer, which invalidates and undoes everything that we did today up until that moment, or we can recognize and agree that we haven't gotten where we need to go, and so we need to regroup and take some new approaches to resolving this issue tomorrow. And usually I find students are agreeable to the idea that, like, okay, I recognize I'm upset that I don't have an answer, but also I realize that we just haven't worked our way to it yet, but my teacher's not going to leave me hanging forever. Um, and I had another thought and it slipped my mind.
You can talk. They can't hear me. You can't eat, right? No. So you guys go eat without me. I'm just gonna snack.
But yeah, I think it's important though that, if it's the end of the period and we haven't resolved our discussion, for me to just say, here's what I think is the right answer, what was the point in us having that discussion in the first place? And so, am I going to hold to my convictions about why we have these conversations in the first place, or am I just going to be the teacher who gives the answers? And so that's why I want to leave issues unresolved when we haven't come to a natural resolution. I'm sorry, Tiffany.
That's okay. In that situation, how do you bring closure to the discussion, to the students, so that they can't, even though it's unresolved, you can still close up the discussion? And so how do you do that?
Yeah, I figure, like, if I realize there's about 2 minutes left in class and we've got no chance of getting to a resolution, then I just need to step in and say, hey, everybody, I can see, you can probably tell that we're not gonna wrap this up in a way that satisfies us today. So let's just recap where we are. Here are the issues that we're discussing. Here are the different thoughts we have about this. And so, let's all just think on this as much as we're able between now and then, and let's just come back fresh, and I'll think about new ways that I can ask you some questions so that we can work this out and come to the resolution that we all want tomorrow.
Yeah, if I could add something to that, Jeremy, is that what I do is on my phone, because I'm a talker, and my goal is to have my students talk, obviously. Mm-hmm. I put a little alarm on my phone for the last 2 minutes of the period, so I know, so it's not like all of a sudden somebody's, like, my students know that, said I always have a 2-minute warning. And then if I'm in a discussion, I'll say a student, say, okay, we're not done, but have no fear, we'll be back tomorrow, or we'll be back on Monday. Who would like to recap what we said? And let a student do that. Because as he said, it's really easy for us to jump in and say, well, sorry guys, we didn't get to what we wanted to today. Let me tell you what I really wanted to get out of it. And I think that is I think that's not really the goal of the modeling, is to really have the students come up with it, and then consensus, you obviously guiding. But I found it helpful. And the students at first are kind of like, oh, what do I say? I said, well, what did you learn? What are we even talking about? What's a question we could all ponder tonight, and then come tomorrow fresh with some sort of input on that. And that's how I end it. But just with the security with the students, like, hey, it's not like one and done. That's what's so great about being teachers, is that we get to see them, I know in my case, at least 180 times a year. And so that we could always go back tomorrow.
Is it, yeah. Julie, I like that you have a student recap. I'm wondering, and it might take more time, if you have the students sort of pair up or in trios, like, hey, come up with one thing, maybe that would be a recap, and then a whole group share out kind of thing.
I definitely have done that. The think, pair, share works great, because it's hard for somebody to talk cold. Right. So to practice it in a think, pair, share, but then I think that would take more than maybe the last 2 minutes of period. So you really have to gauge it and kind of keep an eye on the clock. What's going on. And we also have some class rules or expectations that we've come up with before, as far as class discussions about respective dialogue. And, I have question stems posted in my classroom, to help kids, the discussion to get started. We also talk about, that you not to have the floor for more than, so many minutes. Like, even when I have students going up there, when I do my whiteboards, I used to have them all go up as all group of 3 or group of 4 as a group. And now I'm down to one person. And I'm very much aware that it can't be more than 5 minutes that you're up there, because then even if we're not done, whatever, I usually let the students go. So you just as a teacher have to be really cognizant of the time.
Sure.
But I love, Tiffany, the idea of the think, pair, share. I've used it, and it definitely lowers the anxiety level of the students.
Or assigning students at the beginning, like you four students are recappers today.
That's a great idea.
And then at the end, okay, recap. Who are my recappers today? And so they can kind of collectively share the burden, so to speak.
Right. And rotate that out.
Mm-hmm.
Yeah. Yeah, I'm writing that down. That's great.
And one other thing, as far as not having resolution, something I learned from TV series is that sometimes that's exactly what I want. You know, when a season of a TV show ends, there's a cliffhanger, and it makes you eager for when the show comes back. And so, you know, there are times when I definitely intentionally do that to make people curious for tomorrow. And I think that's a slightly different issue than what Megan had raised initially. But you know, when kids are eager for, I want to find out about this, I mean, that's where I want my students to be. And so it just comes down to managing human interaction, as far as, you know, like, how can we leave this as a cliffhanger for tomorrow without being angry about it? You know, and if they feel like I'm intentionally withholding something from them, then, you know, sure, they're going to be upset with me, but that's not what I'm aiming to do. Although I just reminded myself of something. Has anybody here, other than myself and Teresa, ever heard of a horse by the name of Clever Hans?
Oh yeah. Yes.
So Tiffany has.
Yep, Jeff, Megan is nodding. Yep.
Mm-hmm. So Clever Hans is a favorite story of mine. And this is a true story about a horse who was taught by its owner to do math and answer simple questions. And I think, well, Teresa and I would like for us all to watch a short video. It's about 6 minutes long about Clever Hans. And after we watch this video, then Teresa and I will talk about why we think that this video is worth everyone's time. So we're going to give you, instead of trying to all watch it on Teresa's shared screen, I don't think that works nearly as well as you just watching the video on your own. So Teresa's got the link there on the screen, and I'm going to put that link in the chat. This link is going to look different, but it'll take you to the same place. So I'd like for everybody to just please watch that video, and we'll meet you back here in about 7 minutes. Comments right now. A lot of people are talking about their tells in the comments. And I know that Teresa and I have some very definite thoughts in mind about why we felt that this is important to share. But first, I'm curious what your takeaway is from that. Why is the story of Clever Hans important to us for leading good class dialogue? And I'd open that up to anybody who wants to share.
I know that for my kids, they just want the right answer. So we get into the conversation, and it's not, you know, as much as we can say that it's about the journey and not the destination. They really want the destination. So they want the right answer. So even in conversations, even if I leave the circle, they're still turning around to try to get that reaction from me.
And I'm sorry, Melissa, I'm going to interrupt real quick. Teresa, are we recording again? Awesome, thank you. I'm sorry, Melissa, were you finished or? Okay, so they're turning to you to see, are we on the right track? Okay, anybody else?
I had the pleasure a few years ago of having an ELL teacher work in my classroom. And I discovered that the kids had much better discussions when she would talk to them rather than when they would talk to me. And I found that when I was talking to them and trying to ask the same questions, they were just constantly trying to read my face and see what my reaction was. But because she genuinely often didn't know what the answer was, they would really get into it. And then at some point I would get involved again because they would sort of, maybe they hit an endpoint or they wanted to come and check in with me. And it made me really realize how much the kids are just looking to me to see, do I have the right answer? What is it that you want us to say? Rather than when they were talking to her and they could actually really share what they were thinking without trying to read her face because they didn't think she had the answer.
I think one of the things that I noticed with me is a tendency to nod my head, which of course is, you do it subconsciously without even really thinking about it. And the other thing is, I know when someone's going down the wrong track, I tend to ask more questions of them versus when they're on the right track. And I think that itself is a dead giveaway to the students that there's something wrong, depending on the number of follow-up questions I ask when they're presenting.
I think for me, one of the problems is that they're like in the same way that there's a destination the kids want to get to, there's a destination that I want to get to. I don't want to leave them with the wrong answer. And so that, of course, is playing on my tendency to be too directive in questioning.
I remember when I took my modeling workshop and our workshop leader, when we would present our whiteboards, he had constantly had this look of confusion on his face. And so when you're standing up there trying to read his face and you're like, I know my physics, and 'cause you don't want to be wrong in a physics workshop full of physics teachers. And he just constantly looked confused. And as it went on, because it's many days of workshop, you sort of pick up on, I guess that's a practice or, a way to go about it. And I would try to mimic that. That's what I learned. And so that's what I would mimic and try to sort of play dumb, I guess. But I do agree, because we had a destination, sometimes I'm going to ask fewer questions if they're on the right track and get them going so I can get somebody else up and listen to what they have to say. But
I honestly never even thought about having tells, and now I want to videotape myself to actually see what it is that I do in class, because I never even really thought about it.
So do you all question as the students present, do you question each time a student presents a board, or do you wait till the end when everyone is finished presenting, or do you kind of, it depends on the day and what's happening?
Well, I know for me at first, as a group is presenting a board, I'll ask questions. Now I'm at the point where each group is assigned to somebody else's board. So when they're presenting, their group is in charge of asking that board questions. So I'm really trying to step back, because as you can see, I make a lot of facial expressions. I'm nodding, I'm smiling, I'm like, or whatever, and so they could read me, and I don't want me to be the focus. I want them and their discussions to be the focus. So that's how I got around that, is having group one is going to be asked questions by group three, and vice versa. So, and I switch it up. So again, increase the student questioning. And also, just a little plug for the videotaping. I have videotaped myself. It's amazing how much you learn. And actually, I already have my things for tomorrow is to sign out to get videotaping myself tomorrow, because I want to see where I was as of September, and now I want to see where I am in January and where I am, so on and so forth. And to me, it's a safe way to do it, because I don't have to show that videotape to anybody. I just want to find for myself so I can be better at having increased student engagement and less of me.
Thanks. I love that idea of assigning groups, because when I first started, I was like, okay, we're going to ask each other questions. And they were all like, what kind of questions? So I kind of led the questioning for the first 2 semesters. So I told them, we're approaching the 3rd semester. I said, now that you know what I expect. So I love that idea of kind of grouping them up. So now they can do that together. So thanks for sharing.
And I definitely mix up my approach to that. But at the beginning of the school year, they need a lot of training on how to ask questions. Even if they're confused about something they're looking at, they don't know what kinds of questions to ask each other. And so they need some kind of structure. They need some kind of help in how do I ask questions. If they've never learned how to do that, then we shouldn't expect them to be any good at it.
Yeah, so
And
I have good question starter little sheets. So I've been passing those out every activity that we do to say, okay, this is what I'm going to expect from you. And I think that kind of helped them see like, oh, well, these aren't that difficult to ask each other, especially if they have that core to kind of look off of. So I feel like it'll be interesting now to see that they've been practicing, and then they're going to be able to take it on themselves in this next quarter. So
I did that as well, and I was actually pleased. This is the first year I convinced everybody else to try whiteboarding, and pretty quickly my students moved on from using the question starters to saying, well, can I ask a question of my own? And I'm like, yes, of course you can.
so I heard some people saying things about responding differently, whether they agree or whether they disagree, like how many questions they ask. But if you've been in a classroom for long, you've probably experienced students who can give you the air quotes right answer, but if you do just the smallest amount of probing, they really don't have any understanding of what they're saying. And so giving the right answer to me isn't really an indicator that somebody actually understands the thing that they just gave a right answer about. And likewise, sometimes when a student gives an answer I disagree with, and sometimes it happens so often, a student says something where my initial reaction in my head is, how did that come out of a human's mouth? Like, why would anyone possibly think that? But then, with just a little patience and a little, checking on follow through, it turns out that they have a really great idea. They're just addressing something that only 90% overlaps what I was asking about. And, with a little bit of probing of something that sounds like a terrible answer to my question, it turns out it's a really thoughtful answer, just not to what I was expecting to hear about. And so I find a lot of value frequently in things I disagree with when I give them some space to explain themselves. And I find when students give answers that I agree with, there are a lot of times when those answers are kind of empty. And so keeping those things in the back of my mind helps me try to value things I agree with and things I disagree with on more equal footing.
Yeah, I agree with you that students tend to throw out the vocabulary or terms and they have no depth of understanding underneath it. It sounds very scientific, but it doesn't mean they understand what they're talking about.
Mm-hmm.
I know I find that too. I teach both AP Physics 1 as well as Physics Prep. And some of the AP Physics 1 students will start trying to use terminology for units we haven't even covered yet. And I'll just say, I don't really know that term. Can you explain it? And then I try to help them for us to come to class agreement. Let's only use terms that we've already discussed or we have a firm understanding of before we start using terms, because I love what Laurie says, they sound really smart, but then if you question them about it, they got no idea.
Mm-hmm.
For you guys that have done modeling, do you find yourself asking a particular question or a particular two questions very frequently? And if so, what are those questions and why do you keep asking them?
Well, I know for me, for lab, we always ask when they collect the data, what's the meaning of the slope, meaning of the y-intercept? You know, what are some things? So that's something that we constantly go back to over and over and over again. We also were doing like problem sets or something or whiteboard, and we always go, well, and the students ask, well, what if I change this? Like, what if the velocity double? What happens to the displacement? You know, we ask a lot of what if questions to help them understand the proportionality that we're really investigating. I mean, those are the ones that first came up to mind.
Yeah, and Ariel posted in the chat, what evidence do you have?
Yeah.
As one of those, like, one of those questions that we can always fall back on.
Mm-hmm.
Some of the questions in the chat that have come up so far are related to resources, question starters. I will put this slide back up because this, within the folder that this link takes you to, is a subfolder called I think discussion tools or maybe resources. In any case, we've compiled a handful of things that Jeremy, Ariel, and I have all found useful or heard from some of our workshop folks that that they're good ways to get students talking. And we can talk a little bit more about what's in that resource folder later on. But I know, for example, there is a bookmark. One of our workshop instructors a few years ago talked about how she has her students use the bookmark in their lab notebooks, and then the bookmark has a handful of questions that the students can sort of be prepared to ask and can ask each other. And there are a couple of other resources in there. So, and then I saw that Melissa shared a file, and I will add that to the resources folder as well during our break.
Thank you. So I just want to, looking at the clock, I do want us to move on because we've got lots more to get done. And I noticed right away that a lot of you immediately, just from what you put in the chat, picked up on the big picture that Teresa and I were interested in. What's interesting about Clever Hans is that horse didn't know a thing about mathematics, but Von Otten, whatever his name was, tricked himself into thinking that his horse knew things. And we as teachers need to be mindful that we're not tricking ourselves into thinking that our students understand things when the reality is just that they're responding to our cues. And so, you know, we need to be very careful to check, you know, like, is this actual learning, or are they just saying the things that I'm subconsciously telling them to tell me? And so, you know, as people are talking about their tells, one thing that I've spent years and years and years training myself to do is to have the same reaction to everyone all the time. And for me, that's just having a poker face. You know, so I'm asking about evidence, and I'm nodding, and I've been doing that for the last 20 minutes, I think, just nodding at whatever people say to me. You know, because I want to acknowledge that they're speaking and that I'm hearing them, but I don't want to give them feedback about my opinion of their thoughts. I want the evidence to speak for, you know, so, you know, when they're giving me an answer, like, am I right? And I'm like, do you think you're right? You know, why would you think that you're right? You know, so I want their confidence in their answer to be about the quality of their response, not about my response. So I've trained myself to have a poker face all the time. But that doesn't work for everybody. Like Ariel, I don't think she's here right now. But Ariel can't do a poker face. And so she just has an excited response to everything everyone ever says. But to me, the key is to be consistent, regardless of what I think right now of their response, to have the same level of response. And we want to move on to talking about some specific things about board meetings, and we're going to put you in some groups to talk about questions to ask when we're having a whole class conversation, what modelers call a board meeting. But first, Teresa, you say there are some newcomers who we want to introduce themselves?
Yeah, we had a few folks that were able to join us, but after we had gone around and introduced ourselves. So at the risk of putting you on the spot, I'm hoping that Sue and Nathan will just tell us briefly a little bit about yourself, where you teach, what you teach, and then we'll move ahead. So I'm not hearing from either Sue or Nathan, and I don't know if that means that they have some audio connection issues. We'll see if we can get that resolved. Let's see.
Is there something supposed to be checking?
Oh, Nathan, is that you?
Yes.
Hi, Nathan.
Hi. I teach at Texas High School in Texarkana, Texas, and I teach astronomy and space science. And I learned about modeling a couple years ago at science school. Doing what I can from you guys.
Nathan, are you on with two separate computers? There's a window that says Nathan Upchurch. That may explain the echo.
I thought I closed off the one.
Okay.
And Sue or Heather?
Sue, I think, was having some audio issues.
And I'd like to reiterate something Matt put in the chat, that if you're not speaking, it would be helpful to mute audio.
If my audio is working.
And
okay.
Heather?
Hi,
Heather, hello.
Hi,
Heather.
how are you? Hello. I'm actually on my phone, but I just got home, so I'm logging into my computer. I teach middle school integrated science and freshman bio, and this year physics first. And I am in Naperville, Illinois. And I'm just popping on with, there we go. Now I'm just popping on with my computer instead of my phone.
Awesome.
And for anyone that's continuing to have any audio difficulties, I'll encourage you to use the chat to communicate. I'll be happy to see if I can help you resolve any technical issues that you might have. But we can do that through chat rather than monopolizing the group conversation. So thanks to Nathan, Sue, and Heather. Welcome. And Jeremy, are we ready then to talk about what we're doing next?
Yeah, do you want to take that one?
Sure. So this is something that in just a few minutes, we're going to put you all into some breakout groups. Most of you will be in groups of either 3 or 4. And what Jeremy and I have done is we've put together some whiteboards from our classes. So one of the files has some physics whiteboards, and one of the files has some chemistry whiteboards. I know we have a handful of bio and middle school folks, so we, I think, tried to just mix it up a little bit. But the idea is that in your small groups, you can take a look at the boards that students prepared and try to come up with questions that would guide the meeting, questions that would lead the students in the direction that you want them to be moving toward, that might identify misconceptions, disagreements, and so forth. And we do have some more detailed information and prompts in the breakout session files. Again, just to reiterate, this is, sorry, I'm gonna scroll back here. If you open up the Google folder using this link, there's going to be a folder called Whiteboards for Breakout Session 1. And timing wise, Jeremy, what did we decide? We're going to do about 15 minutes in the breakout groups? And
yeah, 15.
Yep. And then what we'll do at that point, after you've had about 15 minutes in your breakout groups, is we're going to go right into a break. I think everyone is going to need to stand up, stretch, get a drink of water, use the bathroom, whatever you need to do. And so we are going to plan on having everybody back in the full group at 3:28 or so. So if I don't think I did my math right. I think that's only,
well,
anyway, the point is that
Teresa,
in about, yes, go ahead.
Do we want to, before we go into the breakout groups, just establish what it is that we're looking for, or are we counting on the document? Okay.
Well, you why don't you say some of it out loud, and then the rest I think will be in the document.
Okay, great. So thinking about a whiteboard meeting, which for those who don't know the language, essentially our students have all worked on the same task in groups, and now we're coming together as a whole class to share what each group has done and looking to reach a consensus on what ideas can we build out of the work that each group has done. So each group on a handheld whiteboard will have the best representation of their work that they could come up with. And so then we're looking to lead a dialogue on what information can we pull out of this? What understanding can we pull out of this? What can we all agree on? So when we want to have a whiteboard meeting, things that are important for us to have in mind beforehand. And I know just on Friday, 2 days ago, I did a whiteboard meeting that I felt went pretty well in all three classes, although it went very differently in all three classes. But that same whiteboard meeting a year ago, I remember this one because a year ago, I made the foolish assumption. I was busy prepping for final exams and so on. And so I thought, well, this board meeting's easy. It'll take care of itself. Let me work on writing this exam right now. And I didn't put the thought into prepping for the board meeting because it was a really simple lab and it'll be really easy for us all to agree on what we know from this. And that was a terrible plan. The whiteboard meetings didn't go well because I didn't have a clear goal in mind and I hadn't thought through like, what do we really need to get done? What would be nice for us to agree on? What would be nice for us to notice? But what's essential? Like, what do we really need to pull out of this? And because I hadn't put that thought in a year ago, the board meetings were just kind of a rambling disaster. And so I was thinking about that when I had that board meeting, not yesterday, on Friday, and just like what a difference it makes to have a clear goal in mind, to plan for what mistakes are they going to make, to plan for what ideas are going to come out in this meeting and how am I going to deal with that. thinking about those things before the meeting makes all the difference. And so we want you to go into your breakout groups and take a look at the document with whiteboards on them and see what you can come up with as a group for what line of questioning would be productive. What do we want to pull out of this meeting? And how are we going to ask the right questions to get our students there? Teresa, did I cover it all, or is there anything you want to add?
I believe that covers it.
Okay.
Okay, so what'll happen in a moment, for those of you that have never used Zoom before, you are going to see a pop-up shortly, and it's going to direct you to accept your assignment to a breakout room. If there are any issues, I'll be back here in the main area for a moment to kind of help people get redirected. But once you're there, just check to make sure that you are unmuted. Within your small group, you can choose whether to share screens if you all would like to be able to look at the document at the same time. You can feel free to just talk about it and then report back orally when we return in about 25 minutes, or you can feel free to type in, make a copy of the document, or something that you can do a screen share. I'll leave that up to you once you're in your groups. And most of you are in a group of, well, you should all be in a group of 3 or 4. All right, are we ready to deploy?
Yeah, so 15 minutes and working on that, and then a 10-minute break. So we'll see you back here at 3:36.
Okay. I'm going to pause the recording. Was it Jerry? Are you there? Can you hear us? Was he the one that had said that he was going to be leaving after the first hour?
Hi, Zena.
Hi. Was that Teresa?
No, that's Heather.
Hi, Heather. Oh, it's so good to see you.
Yeah.
Hi, Zena. This is Teresa.
Hi, Teresa. How are you?
Good. How are you?
Good.
Good to see you too, Heather.
You too. Yeah. I saw Ariel in here somewhere.
Yeah, I think she had to get back to archery or whatever. You know, she's always doing 17 things at once. So.
Ariel, I see we're recording again. Or Ariel.
I'm Teresa. Yes.
If you were talking about Ariel, I know who you are. You're recording again, right?
I am, and I'm making you co-host again. I tried to make Ariel co-host so she could help me with a technical issue, and so now you're back.
She was when I got booted out.
Mm-hmm. Looks like just about everybody's back, Jeremy. Do you want to? Get started, or? Are we ready, Jeremy?
Yeah, let's go ahead and get started.
Okay.
I think that right now we should just take a few moments for each group to report back what goals they set for that board meeting and what questions they came up with to make sure that whether you ask it or whether other students ask it, but what questions do we want to make sure get asked in that meeting?
And I believe there were 3 groups that were looking at the chemistry example. The chemistry example came from a lab that I did with a they're from last year, and it was the zinc chloride lab. For those of you that have done that, they react zinc with excess hydrochloric acid and then attempt to empirically determine the formula of zinc chloride. And Jeremy, do you want to just briefly introduce what was in the physics whiteboards for those who didn't see them?
Yeah, it's a beginning of the year experiment where toy cars are driving across a track where I've marked out on each track differently from one group to another. I've marked out on each track a number line and a start line and a finish line for a car to drive across, and they're just recording positions versus times for these various cars. So whichever group, do you want to start with the chem group and do all
Right,
three
yeah.
chem groups and then all three physics groups?
Yep, because then I can share my screen so everyone can see the whiteboards that these groups were looking at.
Okay.
So I'll go ahead and share my screen here, and I'll invite, I believe it was groups 1, 2, and 6 were the chemistry groups. I don't know if any of you were paying attention to which group number you were in, but would one of the chem groups like to tell us about your conversation?
Well, we were breakout number 1.
Okay.
This is Brenda.
Hi, Brenda.
So we are all not super experienced modelers, but what we kind of came up with was if you look at the whiteboards, that some kids did a good job of representing each chemical with a particle picture. Different groups seem to get the idea of conservation of matter. So we were thinking of questions that would kind of clarify both of those points and maybe ultimately have the class agree on a consensus for how they were going to represent this reaction with a particle diagram. So questions like, can you please explain, how your diagram represents each of these chemicals? Or, we talked about conservation of mass. Could you talk about how your diagram represents the idea of conservation of mass?
Okay, anything else you want to add from breakout group 1? How about one of the other great breakout groups that looked at the chemistry boards? Does anyone want to talk about the goals of your of the meeting or questions that you came up with?
Well, I can't remember what number we are. This is Zena.
Hi, Zena.
But we also tried to figure out how we were going to nudge the students towards perhaps representing the particles so that the mass was conserved. And so the idea was that we referenced back to an earlier lab. Have you all not experimented and proven and have evidence that matter's never lost? It's always conserved. Do our boards represent what you all have established? And to get them to have that discussion.
We also thought about having the students talk about the similarities and differences between the boards, because 2 of the boards were very similar, and one of the boards was definitely missing hydrogen on either side of the equation. So we thought maybe that could be a sort of open-ended question to start to see if anyone noticed that, and maybe they did on those post-its, but we couldn't zoom in that much.
Yeah, sorry about that. They're too small to read.
A little mystery.
Yeah. And there was one other group, correct, that took a look at this board or this set of boards?
Okay, maybe we have heard
Maybe
from all
not.
three.
Yeah, that could be, yes.
Okay.
Okay, all right.
So with the physics whiteboards, there were 3 groups. So just let us know what big ideas did you want to focus on here? What goals would you set for this board meeting, and what questions could get the group there?
Well, I think the goal that I would like for my students to understand is that the y-intercept represents the starting position, and the slope would represent the velocity. And I know, so we had talked about as our group, and Tiffany unfortunately had to leave for a family thing, so she's not here with us right now. But we thought to first start by having all the boards up and asking the question of, what do you see that are similar in each of the groups? What do you think are different in each of the groups? What could account for those differences? Were some of the questions we thought we could start off with asking, and then see what the students' answers were, and then let that lead to further questioning to hopefully go with the goal, find out that the starting position is the y-intercept. As I said, the slope would be the velocity.
Would it be an appropriate question to ask if they could figure out whose car was the fastest for this kind of lab? Like, to kind of get them...
Yeah,
absolutely.
I think so.
Kind of get them excited about it.
Yeah.
And then ask them, you know, well, you think it's easy to compare those numbers, those findings?
Mm-hmm. Yeah, I definitely think so. I think that could come out of when you ask about what are the differences, and then what could account for those differences. And then maybe come up with a class consensus as to how we're going to represent that velocity. Like I saw even in group 2's board, it's like meters per second. Another group said centimeters per second. Maybe we can come with some sort of class consensus as to how we can represent them all the same way, so that when we're talking about, it's easier to talk about it because we're all comparing the same things.
Yeah, it'll be easier to compare. That's good.
I'm Megan. We're in group 5. We also talked about the same stuff Julie just spoke about, but I would add on, we also had a discussion about talking with the kids about their methods for getting the results they put on the board. So having the students share out how they went about getting it, because oftentimes the graph that we're looking at here is not the most intuitive way for our students to go about doing this particular activity.
And I can say with my students doing this, the ones who are getting a graph like the one on the screen right now with entirely positive positions, a lot of those kids look at other groups that have negative positions or negative slopes, and they're confused. Like, what did you do wrong there? You know, and of course the kids didn't do anything wrong, but what, it was Megan who was speaking, right? Was that Megan who?
I think so.
Yes, that was me.
Okay. What Megan was getting at is, you know, like talking about the method is going to really help kids understand, you know, like why would those numbers be negative, or why would the graph have a negative slope? Then hearing other people talk about that process makes a huge difference.
Could I ask a quick question? So I also teach physical science, and I'm just about to do this. I'm just now able to teach it. And so you will all give them the freedom to make the graph as they see fit the first time? Or do you?
I know for me, when I did it, I gave each group, they had the same toy car, but I gave them like a little Post-it note that said, okay, you start at, like, for example, -50, or you start at 0, and then you have your car moving to the right, you have your car moving to the left, just so that they account for those. You can have some different graphs. So I think that would lead to richer discussion. And when I did this experiment, I did let the students do the graph any way they thought was correct as a group. And then during the whiteboard discussions, that's when we said, okay, we decided that it's probably easier to compare if we're all doing it the same way. And then we came up with a class consensus as how we're going to do position time graphs in the future. What units we're going to use for the position and then in time. So we do further labs. It's easier to see, for example, the speed of the car, which car is going the fastest, because some students will do position on the horizontal axis and time on the vertical axis. And then that makes it, is it easier to talk about how fast something's going in centimeters per second or this many seconds per centimeter? So when I first do this lab, I let them, you get a lot of different, I let them do it any way they think as a group is fit based on the criteria that they gave them on their little Post-it note at the beginning to try to help to make the whiteboards different. That's what
it kind of depends on where you are in data collection and whiteboard meetings and also how much time you have to do the activity, because you could, before you start, have a class discussion of how do we usually express speed, and therefore, what would that mean about the X and Y axis of the graph? If you want to direct them a little without telling them, at least give them that to consider. But I do this really early in the year, and I let them flounder too. And really, we were having the discussion, most groups will measure the time to go certain distances. So if they're following what they've learned about dependent and independent variables, they will put time on the Y axis, And so it just depends on where are you at and what's the points that you want to make with this particular activity.
Right, and I think that goes back to the question of what's the goal for the whiteboard meeting, and then the questions that you ask will really be driven by what your goal is.
So one of the things we talked about in our breakout session was getting them to try and articulate their description of the motion of the car as moving at a constant speed, and how the graph says the same thing. How does the graph say constant speed?
So multiple representations, right? Verbal versus graphical.
And also understanding how mathematically a constant speed appears. How do these two multiple representations connect to each other?
Another idea just came to mind. I try to stress with my students, especially when they're doing multiple representations, is just to make sure that each of the representations tell the same story, and make sure they're all in agreement. I know something else I do is motion maps. It wasn't here, but I would have, that's something else that you could add on, is having the students draw a motion map of the motion of the car as well, just to make sure, giving them more ways of representing the same story. Like each thing tells the same story.
Well, and if you also wanted to do it twice, you could have them do time as the thing they were controlling, and then you could relate that to look at the spacing of the dots. Isn't that like a motion map? You'd have it depends on, again, what your goals are, what you want to get to in this particular activity.
Yeah, and only you can know what do my students know right now, and where do I want to get them to go to as a result of this experiment, as a result of this whiteboard meeting. And so, there's so many different ways that a teacher could take this one experience and, have your students made motion maps by the time they do this experiment. For some teachers, the answer is yes. For others, no. Have they tried doing, like, are you exploring the idea of what's the independent variable, what's the dependent variable, how does that affect what my graph looks like? These are decisions that you're making as the teacher beforehand about setting up the experiment, and then that also drives what do I need my students to pull out of this. And there's so many ways that we could sequence those things, but I mean, I'm hearing a lot of really great ideas about what's important, and and also, you know, focusing on what's not important right now. There are all kinds of little details that we could pick apart on any of these whiteboards from either the chem or physics boards. But are those the details that we want to spend our class period on? Some of those things, you know, I'm just going to note to myself, like, oh, I wouldn't have chosen that, but that's, you know, that's a 20-minute discussion that is going to just pull us away from the main point of this experiment. So I'm just going to make a note to myself to address this another time so that I can have a clear, coherent, these are the important things that we're talking about today.
I will say at the very beginning of the year, when I didn't give any specification, I just had if your group graph the data, I got bar charts for experiments like this, you know, where students don't recognize that it's continuous state. We end up having a discussion about when do you use the bar chart, when do you use the line graph, how do you decide when to do it, you know, because it was fascinating to me. It never occurred to me a student would draw this as a bar chart, but that's what I got on some of my whiteboards.
Oh, yeah. And so you're not seeing that on mine because we had already had that discussion like 4 or 5 class periods ago. And so, you know, my students did those same things, but we've already worked through that. And so we're seeing similar graphs. And we've talked about independent and dependent variables in the same sort of way.
You hear from all representatives from all groups, all 3 physics groups?
No, we have one more group. This is
Okay.
Heather.
Oh, great. Yeah.
Our group's important ideas for the physics was we wanted them to recognize that not everybody's origin or starting point was the same. We wanted to try to get them to the point of the negative velocity by way of a negative slope, and that constant velocity is a straight line. So some of the things that we started brainstorming for questions was, of course, what do you notice about the boards that's the same? What do you notice about the boards that's different? We wanted them to go through and check if the math was correct. You know, say, is the math correct on all of these boards? And even if the math were correct on all of the boards, well, now they're starting to really look at the equations differently and say, okay, well, what's different about the equations, and kind of bring their attention to the math in that respect. And then how is the motion of the cars different, to kind of try to get them to start expressing, you know, speed and time and direction, and starting to cement some of those ideas. But that's about as far as we got. This was hard for me. My kids have actually just ended slope, having already gone through velocity and speed and displacement and all that stuff without the math. In fact, I had to tutor one of my students to get her to stop applying slope and tell me what was going on with the motion. And she had a very hard time doing that. So I'm looking at this and saying, this is the last part of this process, and in Jeremy's class, this is the jumping off point. So that was interesting.
And I imagine that varies a lot within this whole group, depending on what age group you're teaching, whether you're teaching an honors level or a grade level class. For me, you know, my previous job, chemistry, was before physics, but now where I teach, chemistry comes after physics, so it's a whole different ballgame in terms of the language they know and the things that they're ready to talk about, and the things they're already not ready to talk about because it's been a while since they've taken biology, for example. So these are all things, you know, that I think there was a question earlier, are there standard prompts with the AMTA materials? No, in part because the teacher needs to make those judgments based on who their students are. And a set of questions that works great with a group of 9th graders taking physics first is not going to work with students taking 11th grade physics. A group of questions isn't going to work with kids taking chemistry in 10th grade versus 11th grade. So it's sort of a process of being able as the teacher to think about what are my goals for this activity, what do I expect to see on the whiteboards, where do I want the students to go with this information, and so the goal setting is a really important step. And then, as Melissa indicated in the chat, we all need to clone ourselves so that we have multiple of us. Help ourselves out.
Listen, I just want to say you have to be careful not to make assumptions about their math ability. I teach an honors class. A bunch of those kids were in pre-calculus, and they forgot how to graph because they haven't done it for a while. They've been working on other math skills. And so it was really shocking to me when I did this for the first time to see how little they retained sometimes.
And I had the opposite problem. The kid I had to tutor could not think about the motion and remove the math. She was such a math intensive kid. But when you try to tell her, you know, okay, but tell me what's going on. And now we have to go back to actually doing the cars and all this other stuff and what have you.
Yeah, and I think that's why it's so great when you have the multiple representation. Have them explain it in words. Have them write the graph. Have them get the equation. Have them do the motion map. And constantly do that so that you can really see what the heck's going on. I love that somebody made this comment about walking around while they're making the whiteboards, just to make sure that, because it said that was from Megan. Yeah, too much student thinking is hidden unless I happen to catch it as I move around while they work. That's huge. So you can hear the discussions and understand and even help to direct what they're actually putting on their whiteboard and just maybe give them some other things to think about. I like that you made that point.
I think that's so important. Like to know what students are putting on their whiteboards and to, as best you can, because there's only one of us in the room, you know, as best you can to be listening to what's driving their decisions about what goes on the board, and what they're saying to each other that isn't making it onto the board. Because kids can't fit everything on the board. And so just to know what their thinking is beyond what's on the board is really important. And to just be paying attention to what our students are thinking beforehand is going to help me make decisions about how I want this meeting to go. And I'm going to change my mind about what needs to be addressed and what doesn't need to be addressed based on what I'm hearing from them. And what goes along with that, you know, just something that, well, we should know what's on every whiteboard before we have that board meeting. I don't want to be surprised by any group's board. It's my job to be paying attention to what they're putting on those boards because that helps me plan. If I'm surprised by what's on the whiteboards, then I needed to be paying closer attention. Now, having said that, of course, there's always that group that in the last minute, when I was sure that I knew what everything was on their board, I turned my back and they changed it all. But you know, as a general rule, I want to know what they're doing before we go into that board meeting.
I think most of the things that we've talked about are on this slide, and most of these came up within our discussion. Again, knowing the goal, making sure you have in advance the idea of what's the concept, idea, skill that students should be able to walk away with, whether or not you're going to be able to reach a consensus or whether you're willing to leave it a little bit not quite wrapped up before class is over. Misconceptions and mistakes are big ones, and that's a sort of one of the things that we do in modeling is we design everything around trying to evoke those misconceptions and then deal with them head on. And that walking around part is not to be underestimated. Not only does it let you overhear conversations that you won't hear once you're in the big the big group. It, as Jeremy said, allows you to make sure you're not going to be surprised by anything. And then importantly, and this happens to me with some frequency, if there's something really important that I want to address and not one single board has something that's going to allow me to make that point explicitly, then I'll I'll plant that seed. I'll whisper it in somebody's ear or make a subtle or not so subtle suggestion to a group. And that's always a good way to do it, so that you don't wind up having that whole board meeting fall flat simply because there's nothing for you to talk about or no good questions to ask once you see 6 identical boards, for example. So seeding is a really good strategy ahead of time if you have an idea of what you want to talk about or something that you want to make sure students notice it on another whiteboard. Sometimes you can subtly encourage one group to make that change.
Can I just say that 6 identical whiteboards is boring?
So boring.
And like, it's boring for me and it's boring for my students, and nobody really wants to engage when everything just looks the same. Like, so I definitely want to plant different ideas, in my conversations with kids, or in those physics whiteboards. The idea of velocity hasn't occurred. Like, we haven't talked about velocity yet in my class when my kids made those whiteboards. And so I want to bring up the discussion of, like, why does your line go down instead of up? And so that way, that plants the idea. My students are the ones who did it, but also they did it because I planned for it. And so planning for ways to make the whiteboards be different in subtle but important ways can have a huge impact on the quality of your board meetings, because when everything is identical, people lose interest really quickly. When people are confused, like, wait, why does yours have a y-intercept? That doesn't make any sense. When people are confused, then it changes the way that they're paying attention and the way that they're engaging.
Yep.
But what Teresa brought up about how sometimes it falls flat. What do we do when our prompts do fall flat? And they do for all of us at some point. So does anybody want to share any thoughts on how to react when the students just don't respond to our prompts?
I've got 2 things that come to mind when I heard your question, Jeremy. Thing one, I'll name the mood in the room. It seems like y'all are really not engaging in this. Is it because it's last period on a Friday afternoon before spring break? So one is the mood of the room. And then the second one is, I'll say, oh, I'm noticing nobody's responding to these prompts. Maybe another thing it could be is you don't understand what I've just asked you. So oftentimes kids will say, yeah, it's that one. We had no idea what you were asking, so I'll rephrase my question.
I love that response, Megan. Thank you so much for that. Yes, I'll just co-sign to everything Megan said there and leave it at that.
When I have groups and I ask a question to the whole class and nobody responds and they look at me really confused, I usually rephrase it and give them time with their actual lab team to discuss it and then come back. Because then it gives me a little bit of time to think, okay, how can I extend this, and I can listen into their conversations and see if there's something that I asked that didn't, something that's not quite connecting, so I can rephrase my questioning a little bit better.
I will try and get students talking on their board, and then I'll start asking more and more probing questions. Eventually, you'll always hit the level at which they don't understand what's going on. And once you can finally get to that point, then you can open up the broader discussion. Because kids at this level, you can always get to the point where you can find what they don't understand.
Coming back to something that Melissa was saying, it is so hard. You've got 20 some, however many kids in a room, and you have to adjust your decisions about what you're going to do and say on the fly the whole time. That's hard. And we should acknowledge that, like, this is a hard job that we're talking about doing. And so sometimes I need a minute to regroup. And so that strategy that Melissa said, for one thing, it gives kids a chance to regroup. And it gives me a chance to regroup when I say, okay, so this thing that we're stuck on, take a minute with your group, talk this out, and in a smaller group, it's a whole lot easier to try out ideas that you might not want to share to the whole room, because nobody likes looking like a fool in front of a bunch of people. So we can try looking like a fool in front of 3 people. So, take a minute, talk to your group, gives them an opportunity to rethink, gives me an opportunity to rethink. And I find that to be such a helpful strategy. And yes, I love it.
Sometimes what I've found is that the questions work great in B block and poorly in D block, for example. And again, that's just part of what's challenging about the profession and about the style of teaching, is that it may work great at one time of day and not so well on the Friday before spring break. It might work great with one group of students on one day and poorly with another group. So I think it's helpful to have some sort of backup strategies, and some of that comes with just having been a teacher for long enough to have tried and failed, and have had some ideas about what to do next. So, for example, for those of you that saw the pictures from the chemistry whiteboards, those sticky notes were specifically because it was a small class and everyone was super shy and no one ever wanted to talk. And so I gave them specific questions, things to look for, things that they agree and disagreed with, and they had to go put post-it notes on each other's boards first before we had the big meeting. Sometimes you could potentially set it up where 2 people stay with their board and 2 people rotate and go to look at the other board. So there are ways that you can sort of mix up what's happening in the room prior to the big meeting to give them a chance to kind of think and look at each other's work. And those aren't things that you have to do every time. Those are things that you could sort of pull out of your back pocket when you're just stuck in that one class where nothing's moving forward.
And I mentioned a board meeting that I ran 2 days ago on Friday, where, the previous year it had gone badly, and because I didn't plan properly, and this year I had 3 really good meetings, but they were all very different from each other. And so, because I was focusing so carefully on planning this one, I had a strategy in mind for how to run this meeting, and I had a backup strategy. And with the first of the 3 classes, my number 1 strategy went great. With the second class, that number 1 strategy fell flat on its face. And so I had to just regroup and okay, let's fall back on the backup strategy. And, so I just tried a different line of questioning, and that line of questioning worked for that class. With the third class, a combination of those 2 approaches got us to where we needed to go. But, so just having, okay, when this fails, what else can I try?
Hey, Jeremy, can you talk more specifically about what exactly happened in your class? Because I'd like to hear what your main strategy was and backup strategy was.
Oh, sure. Well, the experiment was just a Hooke's Law experiment, where, we're just investigating because we're about to launch our energy unit once we're done with final exams. And so, I just want to get my kids thinking of, what's the relationship between how hard I pull on a spring and how far it stretches. And so one thing that I seeded when we did the experiment was that some of the students were graphing the length of the spring, and some of the students were graphing how far does the spring stretch. Because then that leads to a difference in how these graphs look that we can talk about. And prior to doing the experiment, some students noticed like, hey, that spring seems like it's a stronger spring than the other ones. Like, oh, what do you mean by that? Like, well, because you've got the same mass hanging from each of them, but this one stretched farther. So kids had ideas, and I had heard those ideas. So when I ran that board meeting on Friday, first I had them go around with sticky notes. And I love the sticky notes approach, and the direction that I gave them was, put sticky notes on other groups' boards with either compliments or questions. And I don't want criticisms on the board because people shut down to criticism. And so if you disagree with something that's on a whiteboard, you need to figure out how to phrase that as a question, a non-judgmental question. Why did you do it this way, etc.? Because maybe what they've done, maybe you're the one who doesn't understand the good work that they've done. So, coming in on the attack isn't the right move here. And it shuts down dialogue. So you can give compliments. Like, I really love the way that you showed this visually and graphically and verbally, or, a compliment is always going to be well received. So compliments or questions. And what I really like about that is that it gives a low stakes way for every group to have interacted with every whiteboard. So every kid knows what's on the whiteboards before we have our board meeting. And they already know some things like, oh, this makes sense to me. I'm noticing that on all the whiteboards. I'm confused about this thing. So the first thing I tried with one class on Friday, the first class, after we had gone around with sticky notes on all the other groups' boards. So what questions do you need to ask other groups to get clarity for yourself about understanding everyone else's work? And so then immediately one girl asks, like, I don't understand why some of the groups, like your line doesn't go through the origin, but ours did and some other groups did. So why is that? Great. That was one of my goals. And then other kids are asking questions about, like, how did you choose to represent this equation? Because, the groups have an equation written on the board. And by the time they were done just asking each other questions for clarity, the class was almost over and we had hit every idea that I wanted to make sure the kids hit. I was so excited about that. And then the very next period, nothing. The same prompt, same wording, and it's just a different group of kids, and they're like, I'm good. So then I asked, like, okay, well, what similarities, what differences do you see? Somebody had brought that up earlier. And so then they start talking about similarities and differences. And then the same kid who had suggested the day before, I think some of these springs are stronger than others, says, like, well, I see some of the slopes are steeper. And I think that means that they're stronger. Oh, now that's interesting. And then the conversation died down a little bit. And so then I just redirected, like, okay, well, yesterday you thought that some of my springs were the same and some of them were different. So I do think that some of the springs here that you all used are same and some are different. So can you all figure out which of my springs are the same as each other and which of them are different? And that was the prompt that got them all to the place where I wanted them. So I had to work a lot harder that class, but having a couple different thoughts about what questions can I ask them is what got us there.
can I ask how you set up the experiment in the first place so that some students measured just delta X and some measured the whole length of the spring?
Sure.
Sorry, can I interrupt and maybe ask if we table that for later, just so that we
Sure,
don't get
no
too
problem.
more sidetracked with that specific one. I'll make sure we have our contact info up at the end so that we can follow up with that.
Yeah.
But I want
Thank
to
you,
make sure.
Teresa.
Yeah, I want to make sure because we're time management is always challenging in teaching, but there's so much to talk about, and I know that we've only started to scratch the surface. Are there any sort of closing thoughts or any remaining questions that you might have that are related to conducting questions specifically in a whiteboard meeting type setting? There were a few other items that we asked about in the poll, and they were more or less tied. The whiteboard meeting questioning was by far the most popular request, but some of the other questions, questions about questions, were relating to either whole class conversations or instances where student groups are each presenting something slightly different. We won't have time to go through all of those. But we could certainly spend a couple of minutes talking about strategies for each of them. We can also circle back to some of the resources that we touched on at the beginning related to giving students talk stems and setting up a classroom culture that is conducive to everyone participating, people monitoring their own airtime and not talking over each other, for example. So there are a lot of things that we could still talk about in the time that remains. Does anyone want to make a request of where we might go next in our discussion?
I had a question. I wonder if this would be appropriate to ask right now. There was something that came up earlier about managing the spread in the aha, I get it moments from the kids. Feeding the horse to death when half your class gets it versus 2 kids in the class gets it.
Teresa, I think that really speaks to the idea of, yep, there you go.
Yep.
Okay, you take it.
Okay. This is, there's a video link which you can find in the materials we've shared. I don't know how many of you have seen or heard of this Learning Pit. It's about a 10-minute video, but I show it to my students at the beginning of the school year, and I have this graphic actually hanging up in my classroom. The general idea is simply that I let my students know that I'm going to try to push them into a learning pit, and I'm going to try to keep them down there as long as I can. And if someone comes out the other side, I will try to push them back in. And if they come out the other side and can't be pushed back in, then it's their job to help their classmates work their way out of the pit. And it's not perfect, but using that as kind of a framing device for the way that I want my class to run and the way I want students to work with each other and think about what we're going to do in class. It's helped a lot with dealing specifically with those students who figured it out 35 seconds in and are checked out and now ready to go work on their history essay that's due next period, or play a game on their phone, to sort of hold them responsible for being part of the class, helping students that are really way back early on, and also to, by extension, sort of solidify their own thinking, because once they get it, they decide they've gotten it and they're good to go. But if they have to go explain it to somebody else who doesn't quite understand it, it often forces them to rethink it, to restate it, to show it in different ways, and does it helps both the class culture and it helps, I think, students on both ends. So it's not a it's definitely something that takes a little bit of time investment early on. But it's a short video, and it's something that, I mean, my students, particularly there are 2 classes this year that they never stop talking about the pit. Everything, everything that they find even moderately confusing. Miss Marks, I'm in a pit. Oh, I'm back in the pit. I thought I was out of the pit. And they're 11th graders, and so sometimes they say it with, you know, a little smirk on their face, but most of them, you know, really use this as a way to express how they're feeling about the topics that we're discussing in class that day. So I'll give a very enthusiastic recommendation that you all bookmark this video, watch it at some point, and think about how you might use the idea with your students in your classes, especially in those classes where you've got a larger spread of students that are really struggling at one end and borderline bored at the other end.
And another thing that I think is really important about kids coming out of the pit, we've all had experiences with students who thought they understood something but didn't really. And so, and something that's addressed in that video is that it's the job of kids who are out of the pit to try to help pull kids out of the pit. And it's also the job of the kids who are still in the pit to try to pull kids who think they're out back down in, so you don't let anybody get away with easy answers. And I think that really pushes, you know, like Megan's question is, you know, like, what do you do when you've got, you know, some kids who have figured it out and other kids who haven't? Then that helps ensure that those kids who think they've figured it out have really figured it out.
I also, and partly this just stems from my own interest in adding more to, in terms of metacognitive skills and being invested in my students understanding a little bit more about the cognitive science um, that is the basis for modeling instruction and similar pedagogies. But when, you know, when they say they're confused, when they express that they're frustrated, I'll say, that's great. That means you're learning. That means your brain is making connections right now. And if somebody else is just sitting there on easy street, be like, well, great, you're not really learning anything right now, are you? And so it almost becomes a mark of shame that you learned it really fast and aren't feeling confused or frustrated at all. So it turns the tables a little bit and puts the gold star in the kid that's having a big struggle in the middle of class versus the kid that is apparently finding it all very easy. But that, I mean, that depends on the student population too. You'd have to gauge whether that little trick will work for your particular group of students. Sorry.
I also saw in the chat a question about setting up a culture for collaboration. Does anybody have any thoughts on setting up culture that they want to share? Does anybody have any additional questions about that they want to ask the group?
One of the in the training I went to, there was a big advocate of visibly random grouping, so that you're not always sitting with your friends and you're mixing with kids from the other class. And so what they did and what I've done this year in my classroom is I have my tables grouped and I have a famous scientist name over the table. And on days where I want to have visibly random grouping, they pull cards as they come in the door and they go sit in that group so that they work with different people over the course of the year. And we have some discussions about the benefits of that, or even if they're not your favorite person in the class, maybe you'll learn something from them, and you can always tolerate them for 1 or 2 class periods no matter what. So we have, but I think I've found that the visibly random grouping actually helps discussion. Rather than you're sitting with your friends, they're always relying on the same person who's the math whiz who always knows what they're doing.
I randomly distribute my students into groups of 3 every week. Monday, new groups.
The only thing I'll say about the pulling the cards is they don't feel like they're being manipulated by me, because sometimes they end up with their friends and sometimes they don't. And if I do want to group people specifically, then I out and out say I have a particular reason for grouping kids this time.
Mm-hmm. Yeah, and the visibly is a really important part, I think, of the visibly random grouping, so that students don't think like, sure, my teacher said it was random, but come on, we know better. You know, they see the randomness of it. And another thing that I think is really important about uh, changing groups frequently, and something that needs to, along with that, needs to be addressed explicitly by us as the teacher, is that there are a lot of ways for a human being to contribute to a group. And not all of them are the ones that are obvious in terms of what we think about as traditional, like what's a traditional good science student. There are a lot more ways to be valuable to a group of people doing science than what we traditionally discuss. So talking about what value can different kinds of humans bring to a group is, I think, really important, so that there aren't kids who, so that kids don't like sort themselves into different strata of like, well, you know, I've got nothing to do here because I can't do math, or, you know, like I don't get it. So, you know, so just different ways of contributing is important for us to talk about explicitly.
One of the things that I like to do when I hear that little lingo about I'm not a math person or I'm not a science person is to challenge that story and say, oh, isn't that interesting? And ask them, well, your story's not all written yet, is it? Are we done here? And sort of say, can I even have that story? Will you give me that story? I literally will hold up my hand and say, can you put that story in my hand and say, let's write a new story. Something I found helpful for letting kids go, yeah, maybe this is not all figured out yet.
We've also
I like that too.
We've also been trying to talk about a collectivist class culture as opposed to an individualistic class culture. And there's a graphic, I don't remember where I got it, but it's a nice sort of contrasting chart of, you know, it's all about individualistic. There it is. Yeah. Is that culturally responsive teaching in the brain?
Mm-hmm.
Yeah. Great book. So using that works really well with the whole modeling idea of that we are constructing knowledge collectively and collaboratively, and that we are not, it is not about your own individual achievement in this class.
Instead of groups, I call them teams, and then they each have a role in that team. So there'll be the coach, the scorekeeper, the reporter, the fan. So each one of those is broken down into like a specific goal that they have to complete during that lab activity. And they don't have to do it on their own. They can designate people to help them during that time. So it comes back to that whole team and collaboration mentality that kind of helps out.
I think too, I'm a big fan of intentionally random grouping, and I change them about once a week. And it's made a big difference. But I think the opposite end of that is that there may be times, depending on your curriculum and the particular needs of the students that you have. It's one thing to say, well, they're just, you know, there's just a spread. It's another thing if you have students with specific IEPs or specific 504s that you have legal obligations to meet, and you may find it challenging to meet those obligations if you are using random groupings. Sometimes homogeneous groupings can be effective if it's used carefully, and if you have a topic that has a variety of ways for students to express their understanding. I think that's where the multiple representations that we often show on whiteboards are super helpful. My students who have told themselves the story that they're not so good at math are often just outstanding at particle diagrams. And that's not a small thing, particularly in chemistry, where we really put a huge emphasis on the particle diagrams, on the microscopic viewpoint. So I think that there are ways that you can, when you need to, differentiate in your classroom in a way that doesn't have the appearance of I'm dumbing it down for these kids, but rather values different ways of knowing, different ways of expressing the knowledge and the understanding.
I think too, for creating a good culture, and especially because we're talking about having dialogue, I think it's essential to establish from the start that these are the norms for how we talk to each other in the room, and revisit those pretty regularly as needed. And like the kinds of norms that I'm thinking of are, and somebody asked this in the chat earlier, I think, like, what do you do when you've got just a handful of kids who do all the talking? Is that we want to balance our listening and our talking, because good communication involves both sharing our ideas and listening to others' ideas. And so if we're just waiting for our turn to talk, then we're not really fully engaged in communication. So balancing our talking and our listening, also because we value the differences in other human beings and the perspectives that they bring to a problem. And also that everybody should be comfortable to share their thoughts, which means, if everyone feels safe in the room, that they're not going to be attacked for who they are, they're not going to be attacked for what ideas they say. Just the idea that everyone in the room has value as a person and as a contributor to science. Although being safe to express our ideas isn't the same thing as never having to feel uncomfortable with the ideas that people are sharing. Nobody likes to be wrong. So, you cannot feel comfortable with the idea that somebody's sharing is a different thing from feeling safe as a person. And so, I've got a set of class norms posted on the walls of my room for how do we talk to each other when we're here, and putting an emphasis on valuing each other as people, balancing our airtime, and just readdressing those and the reasons behind them over and over and over.
Jeremy, would you be comfortable sharing that post, that list that you have with the group?
Actually, what I have posted on my walls, I have posters that I took directly from the American Physical Society. Has an initiative that's fairly new and has been evolving pretty rapidly called Step Up. And the Step Up program, there, Teresa's got the link for it, stepupphysics.org. The Step Up program has 3 components to it right now. A lesson about like what can you do with a physics degree, a lesson about women in physics, and an everyday actions guide. And the everyday actions guide, because like our biggest problem in physics specifically is a cultural issue of there are gatekeepers of who gets to do physics and who doesn't. And so we want to break down those barriers. And so the Everyday Actions Guide is about helping teachers reflect on, do I speak to all of my students in the same way? Am I encouraging of all of my students in the same way? Or are there differences in how I encourage one set of students versus another set of students? And a part of the Everyday Actions Guide includes, like there's a poster. If you go to stepupphysics.org and register there, then you can download all of that stuff for free. And there's a poster there that has those norms, and the Everyday Actions Guide talks about why are these the norms that we want to establish.
Nice, thank you.
Sure.
Yeah, and I was going to say, I actually made a copy for all my students of those norms. And so each kid has in their notebook on one side is those norms from STEM of physics. Another one were question starters, for help with class discussion. But on that same note, that also inspired me to talk to one of our former graduates who came back to speak to students about physics and what they're doing in the classroom. So that's also another way of just inspiring kids to stay into physics, is to get somebody maybe you could talk to. I just talked to a student who's still friends with her. Anyway, she came back and it was inspiring just to see all the opportunities that students can do in physics.
Just to make sure it's clear, folks, this document that I have up on the screen right now is called Resources, and it's in that shared folder that also has the whiteboard documents and so forth. So you have access to this already, and so you can open that up and link to that. And we can add more. I'll go back and add in some of the things that have been shared in the chat once we sign off this evening.
And if anybody hasn't read that For Every Speak article, I'm sure there are people here who haven't. I can't recommend that strongly enough about how we talk about our data. So I'll leave it, because we are low on time. I'll leave anybody who needs to read that one, but highly recommend that article, For Every Speak. So is there anything else about culture of the classroom that anybody wants to bring up or to ask for help with?
I sort of on the other end, what about the kids who just don't engage at all? Who seem to think that when you're having the board meeting that's the time to go off into space. I try and call on them and things like, try and get them to participate, but then sometimes they're just totally checked out. And I find that some of them don't realize that that's actually where a lot of the learning is happening. And I'm just wondering if anybody has any tips on how to deal with that.
Again, something that you'll find in the resources that we've shared is the discussion tools folder. I personally have found that providing students with a set of sentence frames and question prompts makes a big difference, along with the explicit expectation that you must ask a question. And that came up in some of the chat as well. A few folks were sharing different ways that they make students responsible for, was that Brenda Marr, I think, was saying, making students responsible for asking a productive question a certain number of times in a semester. Mm-hmm. And Matt shared the question formulation technique, which is amazing, and would definitely recommend that if you have the opportunity to read about it and perhaps attend one of their seminars. But there are ways that I think it's important to eventually transfer the responsibility of asking questions from ourselves, the teacher, to our students. And the sooner we can make that transition, the more fun class will be for everyone, and the more productive it will be. But they do have to be trained. I think a lot of times regardless of the level or age of the students, they are just not used to asking questions of each other in an academically productive way. And so providing them with, for example, bookmarks or question stems or something like that can be a good starting point. One of the files I have up there is called a back of whiteboard menu, and a colleague and I put that together. We adapted a whole bunch of sources, and it's probably a little overwhelming because we've broken it into categories, and I'll again invite you all to just take a look at it. But for example, Early in the year, I will tell each group that they're going to have to ask either a confirm, agree, review question, or a disagree, express confusion question of another group. And then within that, especially early in the year, I'll have some system where there's one person in each group who's responsible for asking the question, another person who's responsible for answering the question, and so forth. So giving them those prompts, especially with teenagers who will play it off as that this is a little silly and they don't really need this, but they usually very much appreciate having the support in their hands and having the excuse that everybody in the class has to do it, so that they don't sound silly when they ask the question.
Thank you.
I was thinking another idea that playing that I've done is at the end of the whiteboard discussion, like maybe have something like on a little exit slip you can give each student and say, okay, I want to, because you know what you wanted to get out of the whiteboard discussion, what were those main ideas, and maybe just have students write down, okay, what were those main ideas? So then you can check in with those students who maybe were quiet, maybe they were quiet because they didn't have anything to share, but yet they still understood. That's very different from a kid who's quiet because they're clueless. And I think it's little exits. You can assess that pretty quickly at the end of the class. You just have them fill it out and turn it in, so you know as a teacher where to direct the discussion for the next day.
Fine.
I just have a little anecdote. I don't know if it's helpful, but this week, so I'm teaching physical science to students, most of whom have IEPs or they have behavioral issues. And one of the kids in the class he's just extremely shy. He can't, it's terribly hard for him to, to talk at all. So I found that there was one student that, made a comment, and it just came to me to say, to ask the shy kid, do you agree with Bobby? And for some reason that was disarming for him, and he was able to open up, and it was somehow made a connection. So I know it's just an anecdote, it's just one thing, but I wanted to share that it worked.
Well, and I have an idea, now it hasn't worked yet, but I actually have a student who has selective mutism, and so for her, speaking verbally to people she doesn't know or if she's not comfortable is impossible. But she can usually talk to somebody in the class that she's comfortable with, so I came up with the idea of her coming up with a question, but then having the other student ask the question for her.
I'm enjoying this silence, and now I broke it, of course. Yeah. But I was just thinking as we were quiet for a little while there that to me this is also a really important move to make, is to just wait and leave space longer than most of my students are comfortable with me just silently waiting. But to me, that is a very important move, because there's always somebody in the room who's trying to figure out, what is it I want to say or ask? And usually groups move on before that kid gets the chance. And so long pauses are okay.
Some things that have come up in the chat, and I think we're also raised it toward the beginning, questions of English language learners, of students with high levels of anxiety, and how do we support them and make sure that they are able to participate fully, but without putting sort of undue burdens or pressures on them. Does anyone have any thoughts on that or want to elaborate?
I have actually quite a lot of English language learners, and I like to do a lot of think, pair, share with them, because I find that if you give them the time to formulate your thoughts and then their thoughts rather, and then do it in a small group, they're much more likely to participate in the larger group because they've kind of had that opportunity to practice saying it first before they have to do it in a big group. And so I do that actually quite a bit, and I found that's worked.
And I think that's one of those strategies that works for everyone, but especially works for English language learners, or especially works with kids who are, for various reasons, feel higher barriers to sharing their thoughts with others.
It's been interesting for me learning the cultural reasons why some students won't participate much in especially whole class discussions. I teach a fair number of international students who questioning or asking or pushing back on an idea is considered horribly rude to a teacher. And so it's been interesting. You come in and you expect a certain amount of, I guess, classroom compliance, and learning that these are cultural barriers, not individual student barriers, has also added a layer of difference to the way I approach those students.
I can actually really relate to that since I teach at an international school. And I previously taught in Romania, and Romanians love to talk. And we had the best conversations in those classes because they would argue about anything. But my current school actually has a lot of Chinese kids who tend to be a lot more reserved and not as into talking. So it's really interesting to see the cultural component in terms of how that changes discussion in the classroom.
I find that the act of having students work primarily in groups and whiteboarding frequently and having the conversations frequently lowers the anxiety level for most of my students that are tagged as having some sort of extreme anxiety disorder, and makes it just lower stakes because they see how frequently we talk, and they see that we do not make fun of people if we disagree with what they said, and that getting the culture of the class is that getting things wrong is good because that's going to lead you to better understanding once you get it right. So I think that just some of the pedagogy itself can be helpful. I used to teach a lot more language learners than I do now, but what I've found is that the process, for example, of using multiple representations helps because they can express their ideas in ways that don't necessarily require them to know every big vocabulary word in the English language. And focusing on the concepts and showing those concepts in different ways can be helpful as well.
I know, I was going to say, in the past, I've told students or had students who have difficulty or they tend to be the quieter ones, I'll maybe pull them aside at the beginning of class saying, today I want you to ask one question. I want you to make one comment. I want you to do, one thing. And just to give them to say, wait, just encourage them to do that, to help them to speak. I think it's helpful because I get concerned a lot, especially teaching physics. And then when students go to college, if they have difficulty talking or communicating in a group, could get lost in the shuffle. So just trying to get those students who are quiet to speak. That's the way I've done it. I've even given them the question to ask. Mm-hmm. Say, okay, at one point in the class, I want you to ask, what's the meaning of your slope? Or what if you double the velocity, or something specific that they can ask to help them to feel a bit more comfortable. And then next time I'll say to them, well, how about tomorrow you come up with the question. You come up to me beforehand, and I try to do it as privately as possible because I want students to always feel comfortable, and I want them to believe that I'm on their side and I'm trying to help them to grow. And I even share about things that I'm currently studying and growing in. Like I got tap shoes for Christmas. And so I tell my students, they ask me, oh, how's tap dancing going, Mrs. Garan? I'm like, well, I can shuffle a little bit. So I let them know that I'm also a learner, and to say the things that I struggle with and learn to help them to say, you know what, it's all about learning and getting better. And that's what I'm here to support them with.
So there was a lot that we had planned for that we haven't gotten to, which doesn't bother me because seeing what direction the conversation goes, we want to go with what you want. But just super quick, one of the things that we had planned for discussing was crafting questions for discussions that aren't whiteboard meetings, where students, with a whiteboard meeting, students have something to refer to, which to me makes a whiteboard meeting a whole lot easier to run than just like a whole group conversation. Like where maybe we're watching like we're watching something happen, or like, hey, I've got this contraption here where one ball is going to fall straight down at the exact same moment that another ball gets hit sideways. Which of these do you think is going to hit first, or whatever, which is going to hit the tabletop first? And only doing that demonstration after the class has talked it out. But like class discussions being different from whiteboard meetings, is there anything that anybody wanted to ask about or talk about regarding that?
I think I was thinking one example is sort of those consensus building conversations you have when the whiteboarding's been done and you're trying to really verbalize the learning and capture it in a way. That time in class when the students feel more comfortable because there's finally some knowledge that we can all commit to. I was just sort of thinking of what those discussions and how those might look a little different.
So when we're consensus building, by this point, we've already had probably lots of conversation, and we probably have a lot of evidence. And so, I would ask for, maybe somebody to summarize, like, what does the evidence tell us so far about what we know here? And, as a follow-up, is there any evidence that suggests that maybe this isn't the whole story? But redirecting students to talk about those things, and always bringing it back to what evidence do we have, what reasons do we have for thinking this.
And any strategies to really maximize the number of voices that are going to get heard in that conversation?
One thing, and this would be very context dependent, one thing that I personally would want to do, thinking about what results my students came up with an experiment, would be to ask somebody, or to ask a group, does the data that you collected match up reasonably well with what this other person is saying. So that gives them something specific to talk about, which to me is one of the big barriers that I find students have, is like, I want to enter this conversation, but I don't know how. I don't know, like, what do I start talking? Like, so to give them something to latch on to, oh, he wants me to talk about our data. So, like, does your data agree with what this person just said? Is a question that most of my students mostly feel comfortable answering or conferring with their group to come to an answer. And the great thing about that question is that you can keep on asking it of all different groups. So, like, whichever kids you feel you want to pull into the conversation, you can just ask them that same question. Like, does your data agree with that also? Did you find anything that maybe contradicts this?
We are very nearly at the top of the hour here, and I want to honor people's time and just let you all know. First of all, thank you everyone for taking some time out of your Sunday to be a part of this. I will be sticking around for a little while. I believe Jeremy will be sticking around for a little while. So that if you want to
Yes.
follow up, ask further questions, have a little bit more conversation, you're welcome to. But because it's 5 o'clock, I would like to make sure that at least 5 o'clock Eastern, excuse me, that if you need to go, if you are in a time zone where it's past your bedtime, you should please feel free to put yourself to bed.
Yes.
And thank you for coming. I'll also just briefly ask if I think it would be great if you all felt that you could contact each other. And so we would like to maybe send an email out to everyone who attended and just make the use the to line instead of the blank carbon copy. So perhaps what I'll ask is that if you do not want to have your contact information shared, maybe let me or Jeremy know, and otherwise we'll just send a quick follow-up message so that you all have each other's email accounts.
Yeah.
Wonderful. Thank you so much.
Yep. Thank you.
Thank you.
Thank you. It's been great.
And also, because I know there are several people here who haven't been to a modeling workshop, and they've commented on it in the chat. If you haven't been to one, I can say for myself, it's by far the best PD I've ever done. And you really get to immerse yourself in this kind of teaching and this kind of interaction with students. And yeah, I can't recommend it enough. Teresa, I think you're hosting a bunch of workshops this summer.
Many workshops. Yeah, we have biology 1 and 2, chemistry 1 and 2, mechanics in middle school.
When will the summer workshops be posted?
A lot of them are already.
Yeah.
The Cleveland that's my organization. We're only hosting a biology workshop this July. On the STEMteachersCLE.org website, registration is open already for biology. And STEM Teachers Mass Bay, you opened registration, right?
We did.
I hear there's a great physics teacher leading your mechanics workshop.
Yeah, her name is Chris. Oh, and some other guy named Jeremy.
And Teresa is going to be leading chem, so.
So
and you've hired.
Oh, go ahead, Jeremy.
Amy. No, please, you go.
Oh, I'm doing the intro to modeling, the online course. It starts Tuesday.
Great.
Once I finish up with that, because I teach physical science, would you suggest a course that I could jump to? Are there any like good online courses to follow up with that? I have a 10-year-old son, so traveling and being away for that long, it doesn't really fit in with my schedule. Is there anything you would recommend after intro?
Heather, I wonder if you have any thoughts on that, because you did the intro to modeling, right? And then you followed up with a middle school workshop. Do I have that right?
Yeah, that's right. I did the middle school workshop in Wheaton in June after doing the online intro to modeling in the spring. But I missed the question. I'm sorry.
Oh, that's okay. I think Amy was just saying that she's in the intro to modeling this year, but may not be able to attend a workshop. And where are you located, Amy? Where I know you.
I'm in northeastern Pennsylvania.
Northeastern Pennsylvania. Okay. Yeah.
There was a tiny bit of overlap between the two, but really not much.
Okay.
And I would
with
say
Amy, actually, I also teach physical science, and I've been watching for a couple of years. Nobody is offering physical science modeling workshops.
All right, thank you.
Yep.
Yeah, I teach physics first using the AMTA curriculum, and I also teach middle school integrated, and so finding the physics first stuff has really been hard. It looks like, for me personally, I would have to travel. That looks like there's a summer workshop in Kansas this year for physics/physical science.
Melissa, Megan, a couple of you who've done the computational modeling, is that designed for physics first for ninth graders? Okay.
Yes, we're doing an online version in January, but it's our wait list is larger than our actual roster right now.
Right.
But which means chances are really good that we'll run it online again in the fall and then in the following spring. So it could become a regular thing that we'll offer it online.
Mm-hmm. Oh, that's
I've
fantastic.
applied to the modeling with computational modeling with Bootstrap workshop in Arizona in July. So I'm hoping that I get into that.
Yeah, nice. And I guarantee to show you how to, maximize your air conditioning usage.
And Melissa's awesome. So if you can, if online is the way you need to do it, then taking a course from Melissa is a great way to learn about modeling.
Yeah, we're gonna try to make the online thing. We want to make it super successful. So Jess Dykes and I are very much putting a lot of work into it to make it fantastic.
I'm excited.
And are those always posted in the AMTA events section?
They should be.
Okay.
Yeah.
Posted in the events section, I would hope, and also just monitoring the listserv to see emails that are saying, hey, here's a thing coming up.
Because none of us gets way too much email, so
right.
It's very easy to keep up.
Yeah, and that can be hard. Like I know Melissa's online computational physics first workshop filled up in like no time at all. 2 days. So yeah, like I read about it and told a colleague of mine, hey, check this out. But he had family in town. So he's like, I'll check it out when people leave town. And by then it was full already. So, that can be hard, but hopefully that means that they'll be able to keep on offering it over and over again.
Well, thanks everybody. I have to go, but I am going to be at the AAPT meeting in Orlando. This is going, and they have a intro to modeling one day kind of teaser, I guess, workshop, which I signed up for.
Great.
And
look, I think Rebecca is presenting. I think she's got a poster presentation on the computational modeling.
Oh, cool. Great. So thank you all, and I look forward to connecting with you again.
Appreciate it.
All right. Take care.
Thanks. Bye. So was there anything else that anybody wanted to ask us? Megan, are you raising your hand or are you waving goodbye?
That was me waving goodbye.
Okay. Thanks for coming.
Yeah, thanks for everything. Bye-bye.
Bye.
Thank you both. I'm going to check out. Bye-bye.
Sure. Bye, Jeff.
Yeah, thank you. This was fantastic. I really appreciate all the resources and the ability to talk to some other chemistry teachers. It was fantastic. Thank you very much.
Thank you.
Great, thanks.
Glad you're able to come.
Same here. Appreciate it. I look forward to taking it to the next level. I love it.
Awesome.
Thank you guys. Have
All
a good
right,
night.
thanks.
Bye.
You too.